Good morning, everyone. How are you? So, as you know, I'm a sped teacher and a co-teacher here, and I'll be helping in Mr. Stewart's class. So today we're going to start about Unit 6, Lesson 5. So by the end of this lesson, you will be able to explain the meaning of quadratic equation by creating a table graph here and overall equation height of falling object. We're going to learn how the falling object will be. First, we're going to start with the warm-up. I'm going to give you 5 minutes and then we'll start. So in the warm-up, we're going to do what do you notice and what do you wonder. We're going to do this and we're going to use the smartboard also. I'm just showing for everyone's convenience. They're still starting it. So you can note down that what you notice and what you wonder. So objective will be, I can explain the meaning of the terms in a quadratic expression that represents the height of a falling object. This is in lesson 5. And I can use tables, graphs, and equation to represent the height of a falling object. So the activity from the falling sky, this is the thing we're going to do in 5.2. So let's reason about the values in some data and build a model. First, we will analyze the scenario as a class. Next, you will answer some question about the scenario and create an equation to model data. Last, we'll have the class discussion about how you created your equation. So when a rock is dropped, this is the thing we are doing in the class. So just want to make sure, like in the video, it is captured. Because some of the students, they are not comfortable, so I can't put the videos there because I already tried it and they deleted. So I just edit and put this thing in the video. Just want to make sure they are not comfortable. So a rock is dropped from the top floor of the 500-foot tall building. A camera captures distance the rock traveled in feet. After each second, write down the possible mathematical equation about the situation. Let's pause to share the few questions. So here the height is given 0 seconds, 0 feet, 1 second fall 16 feet, 3 seconds fall 144 feet, 4 seconds fell 256 feet, 5 seconds fell 400 feet. So what do you think the number tells us? Does the object fall the same distance every successive second? How do you know? You can think and answer me, please. This is the code. Join PD SSQECU. SSQECU. That's the code. It's right here. So everybody got the code? You can enter.
Equation of the height of a falling object.
All right, so what do you notice and what do you wonder? So go ahead and type that in. Can you type it on your screen?
Yes.
You can? Okay, perfect. All right, just wanted to make sure.
Hi.
All right.
I'm Mr. Stewart.
Good morning, Ezra. How are you?
Good morning.
Wonderful. All right, so make sure you get your Chromebook out and log in. So what you guys will look at this and tell me what you notice and what do you wonder.
Everybody got it?
What code?
What
code?
Code
Right here.
is right here.
There you go.
SSQECU. Okay, it's good.
All right, you good?
Yeah, we can
All right,
continue.
so go ahead. All right.
What do you notice and what do you wonder? Just look at the numbers and, you can enter and we can see the... Everybody is doing it?
Did you calculate your answer?
So what do you notice and what do you wonder?
Yeah.
So, did you enter it? Okay.
I'm on.
So everybody is there.
Okay, you need to calculate. You?
Kenneth, did you enter?
Yeah.
Okay.
Okay, what do you know? What do you know? Pay attention.
What is he saying? Yeah, he's been absent for a while. Yeah. Oh.
So he was waiting for the bus to pick him up at home. ¿Dónde tú vives? ¿Dónde te mudaste? ¿Lejos de aquí? ¿Ah? Okay, so what do you notice? What is that? 0 times 0? 1 is 16? What the?
Yeah, just want to make sure, like, what's the next thing we can do. Shall we go for the next one or? Okay.
Increase the Y.
Uh-huh.
Mm-hmm.
Yes, so the X and the Y values are both
So
increasing.
X increasing, right?
Muhammad,
Why didn't you know, sir?
Yes.
answer the question.
What do
You're
you
not
notice?
even paying attention. We moving on. No snack for you today. Rodney, what do you notice? What do you wonder?
What I know is X and Y are increasing.
X and Y increasing. Kenneth, what do you notice?
ER increasing.
They are
Perfect.
increasing? Good.
Ezra, what do you notice? What do you wonder?
Increasing.
Increasing. Does anybody wonder what these numbers represent? We just see numbers. Do we know what they stand for? We don't. Noah, what do you notice? What do you wonder?
That the first 1, 16, and 24 is multiplied by 4.
Okay, perfect. All right. Arlette, you want to answer? What do you notice? What do you wonder about this table?
Both X and Y are increasing.
Good. Foster, what about you? What do you notice about this table?
That's not
Huh?
That's
Okay, all right, okay, perfect. All right, so everybody answered the question. So most of you all said that you noticed that the X values and the Y values are increasing. Very good, very good. All right, so for today, read what it says for me, Rodney, for the first objective.
I'm going to explain the meaning of terms in a quadratic expression that makes sense guide and polynomial.
Perfect. Muhammad, read the second one.
This can.
I can use tables, graphs, and an equation to represent the height of a polynomial and Algebra.
Thank you, sir. Good job. Falling from the sky. What falls from the sky? A lot of things. All right. So, Ezra, read what it says. Let's reason about the values in some data and build a model. What does the first bullet say?
First, we will analyze the scenario as a classroom.
Good job. Noah, read the second one.
Next, you'll have to answer some questions about the scenario and create an equation to model data.
Perfect. Foster, read the last bullet. Wonderful. Good job, everybody. All right. So here we go. Let's read this scenario. It says a rock is dropped from the top of the floor of a 500-foot tall building. A camera captures the distance the rock traveled in feet after each second. It says write down possible mathematical questions about the situation. So, I want you guys to go ahead and think about some questions you can ask from this situation. Okay? All right. Can you type on your screen? Can everybody type on your screen? Yes or no? Can everybody type on your screen, yes or no?
Yes.
You can
Yes,
type
alright.
it, yes.
Alright, so go ahead and answer. What is a possible mathematical question about the situation? So like, so a mathematical question is to be, how fast was the rock traveling? When did the rock hit the ground? So type in some questions. I want everybody to answer some questions. Muhammad, what are you doing? I don't see you doing anything.
Wait, answer some question or ask them?
It says write down possible mathematical questions about the situation. So
Oh.
type them on your screen. Okay?
What do you see? Just write it down. You're writing down?
I brought your pen. I brought your pen.
Did you write it down, Muhammad? No? What happened? You didn't write it? Yeah, you're doing it, right? Right? You're doing? Okay. Yeah, everybody is writing down. That's good. Everybody is writing down. That's nice.
Where do you even buy all this stuff?
The men's store. I went to go get a necktie in the men's store. I went to that.
So what you notice, just write it down
A
there.
couple of them. I bought like 3 of them.
Okay.
Muhammad,
3 segundos.
give me a mathematical question that you would ask about this rock.
The rock is dumped. What are we talking
How about this? Here's something you guys want to write down. How fast was the rock traveling? Type that down. How fast was the rock traveling? Write that down.
Yeah, write it down how fast it is.
How fast? Okay?
Here you can see how fast it can go.
So you
The
can
rock.
say what was the speed of the
The
rock?
rock, how fast it is going. The speed of the rock. Even though it's not physics, it's a math question.
Okay? What's another question that we can ask about this situation?
How the building,
Huh?
how tall is this building?
Oh, we know how
Uh-huh.
tall the building is. How
Yeah.
tall is the building, Ezra?
Yeah.
You what is it?
It's 5
5 what?
feet.
No, look at
5
it.
seconds.
How?
How tall is the
This is
building?
the
Look
time.
at it again. Ice cream.
500 foot.
There you go. So we know
Yes.
how tall the building is. Okay. So we know that the what? So we know that the building was how tall? 500 feet. Okay. So another question you can ask is what? All right. Any questions? We good? Perfect. Everybody's got this down?
Yes.
Wonderful. All right.
Good job.
Almost done.
Yeah, let's move.
So Ms. Fatima's going to go over this with you.
Mm-hmm.
All right. So answer those questions.
What do you think the numbers tells us?
So-
What do you think?
So type that in on your computer.
So does the object fall the same distance every successive second? How do you know? So here you see the building is tall, but do you think the number tell us how you know? And the object fall the same distance every successive second? How do you know? Just write it down, please. Ryan, did you write it down? Mohammed? You did?
Okay,
This
so
is the-
Muhammad, what do you think the numbers tell us? What do you think these numbers mean?
These number tells us about how the rock is.
Mm-hmm.
Look at it on the side. So let's make our screen a little bigger here.
Yeah, this
Can
is
y'all
right.
see that?
Yeah.
All right, so look at those numbers on the side. We have what? Seconds and we have what?
And feet.
Feet. All right, so I want you guys to tell us, what do you think those numbers mean?
This numbers and this numbers, what it
Oh,
is.
wait, I think I know.
What it is called, if it is in seconds, what we call it?
I think it's X.
No, what we see, like, if it's in seconds. And this is in feet, what do you call that?
Time?
Mm-hmm. And this feet, what it will be?
This is how, what are you doing?
how tall it will be. That will be in, like, if I check my height, how long, like, what will be this and this feet.
So here we go. Look at what it says. So the numbers tell us what? The first thing they tell us is what? Look at it. What does it say on the left side? Muhammad, read what it says. It says what? Look at those numbers. It tells us what?
It tells us.
It tells us what?
The seconds and the feet.
Tells us the seconds and the feet. So on your pair deck, okay, when it says what do you think the numbers tell us, it tells us the second and it tells us the distance traveled. So you need to write that down. So it tells you how far the rock has traveled. So after 1 second, the rock has traveled 16 feet. Okay? So Ms. Fatima, you can write that down for them on the board. So what do the numbers tell us? It tells us the seconds and the distance traveled. Okay? So everybody make sure they write that down. It tells us the seconds and the distance the rock has traveled. Okay? Got it? Okay. So what you see Ms. Fatima writing on the board, you all need to copy the
Seconds
same
and
thing
distance
down.
travel, okay?
So seconds
And
and
the
distance
distance
travel.
traveled.
Yes, very good.
So if you have doubt, like, what is feet, how we are measured, like, how much I am, 5'4" or 5'6", like, how we feet, and time we see in the seconds. I say, oh, this is the time, right? So it's
Amen.
it's easy to understand, right?
Amen.
Feet and seconds. So this will be what you think, the number tells us seconds and the distance traveled. So the rock is falling from here, so we can see the time also and also the distance. It looks like we are studying physics, right? Everything is, connected, physics and math. So does the object fall the same distance every successive second, or how do you know? Is it the same?
Now, due to the velocity changing, it would be different every second.
Velocity changes?
Yeah.
So everybody answer it?
Yes. Probably the next one. Does the object follow the same distance every successive second? Or do you know?
So you want to answer that? It's like same or different? This one. Same?
The numbers are different.
How do you know if it's following the same distance every time? What would you need to do to the numbers? So what they're asking you is the rock traveling at a linear distance, at a linear speed? Is it the same distance every second? Yes or no? Okay.
Yes.
Everybody pull out your calculators. Let's go now.
Yes.
I mean, this can be first few seconds. It's 6.
So what's 64 minus, actually what's 16 minus 0?
0.
16 minus 0 is? 16 minus 0 is, Foster, sit down, pull out your
How
decimals.
much it will be? 16.
What's 16 minus 0?
16.
What's 64 minus 16?
4.
64 minus 16 is what?
448.
Thank you. What's 144 minus 64?
Perdido. 64.
What's 144 minus 64, Rodney? Elias, what's 256 minus 144? And
112.
112. What's the next answer? Who did 144 minus 64? Did anybody do that one? Muhammad, what's 144 minus 64?
80.
80. What's 400 minus 256, everyone?
144.
What is it?
144.
100 and?
44.
Good. So, did any of those numbers we subtracted give us the same answer, yes or no? No. So we know it's not what? It's not linear. So they're not traveling the same distance every time. Okay? So we notice every second what happens to the distance traveled. It does what? It increases. So the distance traveled increases every second. Okay? So if the distance traveled increases every second, that means that the speed of the rock is also doing what? It's also doing what? What's the speed doing? The speed is also increasing.
So speed, distance increases, speed increases.
Yep. So as the speed increases, the distance increases. So we call that velocity.
Okay, just
I don't
remember
even think
this.
that's a word, but I probably
The
made it up.
distance, you know,
How you
the
say
more the
velocity in
distance,
Spanish?
the speed will be.
Oh, I was close.
Velocidad.
I was close. Okay, all right. So speed. So velocity is another word for speed. Okay. All right. So how fast you are traveling?
Noah,
All right.
Hours, 7.5 hours, 1.5 or 5 hours. Which one did you mark? Kevin, you are doing it?
I'll give you some help.
No.
¿Y dijo?
So
¿Necesita
where's
ayuda?
$45 at? Right
¿Necesita
here.
ayuda? Ella te va a ayudar.
Did you select it?
¿Está bien? ¿Qué pasa? ¿Quieres salir a dar una vuelta?
So what's
¿Quieres
my
salir a
answer?
caminar?
What's the answer?
Yes, sir. We
¿Quieres salir a caminar?
4.5 what? 4.5 what? Ooh, bless you.
This graph. Those are good students. This graph shows how the total distance there has depends on the number of trips he has made to school. So you can see here number of trips and distance over here is a kilometer. How many trips does there have to make in all? A total of 7 kilometers. Is it 9 trips, 5 trips, or 6 or 7 trips? Anyone answer it already?
yes.
It's actually the same number that it said after, yeah. Yeah, it means 7 trips.
How about Alex? You got the same? Mo? What's the answer?
The answer would be 7.
7.
Where you going? Nowhere. Sit down.
So everybody got answer 7. Alex,
You got work to do.
Yes.
You're not gonna get the phone back.
Shall I
Go sit
mark
down.
it?
Yes. So say 7. Yep. Perfect. Good job. All right.
Let's move to the next one.
Okay.
This one?
Yes.
In Nate set 30 tables from here, right?
Yeah, you can just read the question.
Nate set, okay. In Nate set 30 tables, how many salad plates do you have left? This one, we need to see the. So how many salad plates? If Nate sets 30 tables. 40 salad plates, 10 salad plates, or 20 salad plates, or 30? How many it will be? You can see on the graph how many are there. 30 tables, how many salad plates you have left?
How would you guys do it?
So do you see number of tables and the salad plates here? Robin, can you answer it? How many?
Yes, 30 salad plates.
30 salad plates. Did you answer it?
Yeah.
All right. What did you get? What's your answer, Arlette? 30 what?
30 salad plates.
Good. What did you get, Foster?
30.
What did you get, Foster? 30 what? Okay. So everybody got that right?
Yes.
Good. All right. All right. Last one, and then you guys are going to do your assignment. Okay.
This graph, this one.
Yep.
How tall was the maple tree when it was 6 years old? This tree, like when it was 6 years old, 70 inches, 30 inches, 80 inches, or 50 inches. You can see the age years and the height here. So how tall was the maple tree when it was 6 years old? So what is the answer? Anyone wants to answer? No, you want the answer?
50.
Yeah. Everyone got
Perfect. So how tall was the tree after 6 years?
50 inches.
Good job. See it, Kate. All right, perfect, wonderful. Okay, doke. So we're gonna stop here. So I need everybody to go to your dashboard. Okay.
Yeah, go to the
All right.
dashboard.
And this is your assignment for today. Exactly what we did. It says interpret a graph word problems. So you guys have about 8 minutes. I want everybody to get 100 on this assignment. Everybody.
What is it
Okay.
doing?
Huh?
What's it doing?
It's right here. It says interpret graph word problems. So I want everybody to get 100 on this. So you can work on this now, and it's due tomorrow. Okay? Thank you. So everybody needs to work on it now. It's due tomorrow.
Start working and this is due.
Okay, so you
Kenneth
start
is
working
also
on it
working
now.
on this.
With help?
No help. What you need help for?
With help?
Try to see. See if you can do some problems on your own, Ezra. Because you always say need help, and you can try the problem first. Then if you need help, then you can ask Ms. Burgos, but wait first. I want you to read it and try it, okay? We in high school now, we big boy, right? All right, so I want everybody to get 100 on this. Foster Brown. All right, let's go. I want 100 on this. No excuses tomorrow. If everybody does their homework, you'll get a treat tomorrow. 100% though.
Oh, that's so nice.
No 100, no treat.
Yep.